Okay, most welcome everybody. It feels strange to say that, seeing very few people in the room, but I know that there are many listeners out there in Sweden and also abroad to attend this today's seminar on COVID-19 diagnosis, virus detection, and antibody screening. My name is Stefan Ståhl, and I'm the chairman for the Division of Biotechnology and Life Science here at the Royal Academy of Engineering Sciences. And today I will act as chairman for this seminar. And it's indeed a pleasure and an honor to be able to present these excellent sciences that we have been able to bring together to share their experience for the corona outbreak. And I will absolutely steal minimal time from the speakers, but I will just remind you to use the code you see here at the bottom of the slide if you want to send in questions. So I will present the first speaker, which will be Professor Lars Engstrand for Karolinska Institute SciLife Lab. You have an MD, PhD, and you're a professor at Clinical Microbiology and Communicable Sciences at Karolinska, and you're directing the Center for Translational Microbiome Research. I know that you run a really interdisciplinary research group working in the interface between epidemiology, microbiology, immunology, and genetic aspects of infectious diseases. And I know that you have shed a lot of light on the importance of the microbiome for our health. The key technology in most of your research is high-throughput sequencing. And with that as a start, you will be able to give this very exciting talk, starting up a high-throughput COVID-19 viral diagnostic lab in 4 weeks. Lars.
Thank you so much for inviting me, and well, it has been a quite special journey this fall since January, and I will try to cover up what we have done, not only in my lab, but also in collaboration with the Royal Technology Institute and the SciLife Lab. So, I will try to cover the whole spring from January to May, June, and now what we are doing today. And you can see here that there are not only one place that are involved in this, and we will hear now also from other speakers tonight about the different collaborations. We are focusing on detecting the SARS virus in throat, saliva, and nose samples. And it has been a nice collaboration, as I mentioned, between different scientists and also translational approaches. You all know that this actually happened in the beginning of this year, just 7-8 months ago. It was a pneumonia that was an unknown disease, and in a couple of weeks, WHO were working very hard to find out the cause of this disease. And in the beginning of February, they announced the name for the new coronavirus disease, that was COVID-19. And since then, there have been lots of activities, and you know the situation today. It's not over yet. In the end of last year, 2019, and in the beginning of this year, in the beginning of January, I was, together with Professor Mattias Uhlén at the Royal Technology Institute, invited to give lectures at the MGI site in Shenzhen, southern China. And we were discussing the opportunity to start up a high-throughput sequencing lab for studies of the human microbiome. And we initiated the Million Microbiome of Human project in October 2019. And of course, we were very interested to see if there are opportunities to bring part of this kind of enormous machine park that was presented for us in southern China for use for high-throughput analysis of the microbiome. We didn't think a lot of viruses at that time, and of course we heard in January about the new virus from Wuhan, but no one was really informed about the severity of that disease in the beginning of January. So we went back to Sweden, and I talked to my colleagues, and I talked to Professor Uhlén, and we discussed to merge our efforts to get this high-throughput lab up and running. So we are studying here the human microbiome in health and disease, and as I said, our center aims to become a major sequencing and test site for optimization of this technology in the field of the human microbiome. Then nothing really happened in February. We heard about this virus coming into Europe. It's the outbreaks in the northern part of Italy. But in the lab, we said that this may be a problem for Swedes, but we were not so worried, and we didn't hear anything from any colleagues in the hospital and so forth. But of course, there were lots of worries out there if this virus could also struck Sweden. And then I got this email from one of my colleagues, March 8, 2020, and they said, we have challenges to establish or extract RNA from our clinical samples. Can you help us with RNA extraction and also reagents for DNA, for RNA, for detection of the virus? And at that time, there were this MGI company were working with this kind of diagnostics in China. So they had some kind of diagnostic strategy for this for detection of the virus. So it was not so far away to ask about, are there any possibilities to move this platform into a high throughput coronavirus detection platform? And that means that we should have sampling logistics up and running, of course. We need to fulfill BSL-2 and BSL-3 level security for the virus. So we need an inactivated area in Biomedicum at Karolinska Institute. And then, of course, we needed to have some kind of manual part here to set up the RNA extraction. But of course, to have this in a high throughput manner, we needed to get more robots and more people in the lab. The last part here will be the qPCR, and that's a quite straightforward technology, and we didn't use any dedicated equipment from this company, but of course we were interested to have the entire chain from sampling, logistics, and so forth. So we discussed with colleagues at the KTH, but also at KI and SciLife Lab, how this could be managed in a high throughput way. And of course, there are lots of details that needs to be solved, especially just sampling is not an easy task, and we needed to discuss, should this be sampling by professional nurses, or could it be self-sampling? And that took some time to develop that part of the detection chain. And of course, the inactivation part in the lab was also something we had to negotiate with the Biosafety people at Karolinska, because the people were quite scared about the virus and spread of the virus in the building. Then we had the RNA extraction part, and as I said, we had one of these robots in-house when we started, but we were quite clear that we need more robots if we should increase the capacity in the lab. The qPCR, we didn't have these machines, so we borrowed from colleagues, and it was an enormous experience to see how many research groups and colleagues that were willing to help us to set up this capacity. So in the beginning, the qPCR machines were not in our own infrastructure, but we could get access to them through nice collaborations and so forth. And then there was also a very interesting part to find ways to disseminate the results. I mean, to report the results back to the individual was not so easy, and we had 21 regions to negotiate with to get this up and running. And we ended up with 3 or 4 regions that we serve now, but it is an obvious bottleneck to find out the best way to communicate the results to that region and to the individuals. We were also forced to reconstruct the lab, and you can see here just some of the spaces we are changing into a high throughput COVID lab. And today we have at least 1,500 square meters in this building, the Biomedicum, for COVID diagnostics, but also for the sequencing of the virus. Another challenge was, of course, in the beginning of April to get everything to Sweden. And you have heard about all the problems with transports, borders that were closed, people couldn't travel, and even the cargo flights were cancelled. But thanks to the Knut and Alice Wallenberg Foundation, we had a chance to rent a flight from Stockholm to Hong Kong to get all these 5 tons of equipment ×2 actually into Sweden. And this was a very exciting kind of James Bond expedition, because there were lots of troubleshooting through this journey. And finally we had the equipment in Stockholm, and you can see some of the photos from when we started. This was the 1st or 2nd of April when the first flight arrived to Arlanda straight from Hong Kong. And there were problems at the warehouse in Hong Kong to get everything on board, but finally they made it. Here you can see the amount of material that was actually sent and shipped to Biomedicum. And then we started to set up this lab. We had lots of volunteers from research groups in the building, but also from SciLife Lab and the Royal Technology Institute. So there were lots of support. People were working 24/7 to get this up and running, and that was quite an experience to see this kind of an enthusiasm and support to get this up and running. So we, at the end, we had 1 of these robots from the beginning. Today we have 10 of these RNA extraction robots that are used in a high throughput mode today. We also brought in sequencing equipment from China to be able to sequence the virus, and I will just mention that in the end of my talk, that we have a very high throughput sequencing capacity for measuring the virus mutation and the taxonomy of the different virus types that we see now. So this was also set up with the help of Chinese engineers that were coming here for helping us to get these robots programmed and up and running in a short time. There were also quite a lot of debate about the biosafety here, since we have thousands of samples per day inactivated. This requires, of course, lots of people working overnight, since we have these deliveries from different regions every day. But you can see that this is a very high safety level area where we are working with this kind of protection gear. And here we have some Chinese colleagues coming into Sweden to set up the sequencing capacity, and they were scared to death for Swedes because they heard about the outbreak in Sweden, so they were dressed like this even when they went home to the hotel in the evening. And people on the streets were really scared when they saw these people entering the hotel. But this happened just a couple of days. Then we told them that you can wear masks and you don't need to be dressed like this. But in the beginning, they were actually forced to have this kind of protection gear when they worked in the lab. Then we have lots of skilled people, not only in the lab, but also organizing everything. This is Marika Hamsten, who has been working very hard together with a team, operating team, and there were lots of meetings. We have this room every morning at 9 o'clock to get things organized. I mean, these volunteers couldn't work for free forever, so we had to make some kind of plan for employing these people on an hourly basis, and we had lots of kit packers this summer that helped us to pack all these test kits for sampling that is needed to scale up this. And here you can see me in this kind of protection gear, but most of the area is actually occupied by all these kits and the reagents we are using today. So 5 tons, and then we have another pipeline, and you will hear more about that, with another 5 tons of equipment and test kits. And of course, these robots are now programmed for high throughput testing. This is the RNA extraction robot to the left. So high technology, but at the same time, we need manual help with the kit packing, as I mentioned. And you can see here that we have today approximately 100 people employed part-time or on an hourly basis to help us to pack these kits. And to just organize this is a quite big challenge, actually. The fun thing is that they have some kind of competition here. You see they aim to pack a certain number of kits every day, and there are different rooms, so they compete between the different teams here. So this is quite nice. And these people have all kind of backgrounds. They are postdocs, PhD students, but they are also people, nurses, and students at the gymnasium and university. So this is a very interesting mix, and they are doing a great job. So if we look back, we can say that if we started in the beginning of April, we were working very hard during 4 weeks to get everything up and running. And in the end of April, we had all the machines programmed, and we had the robots tested, and we had validated the test kits with the public health agency, and we got this so-called bemyndigande from the government to have analysis to perform diagnostic tests on COVID patients. And this was, of course, a major risk when we started this, because we didn't know if we should get this kind of permission or not. But fortunately, we got it, and we were prepared to start testing just a couple of weeks after the first arrival of these machines. There were lots of interest from the media, of course, and we were quite exposed here in the beginning. And my thought was, okay, now everything will start running, and we will have thousands of samples every day. But as you know, it's not that easy to get things up and running based on the situation in Sweden with the different regions. You have to negotiate with lots of regions and adjust your pipelines to that kind of system. And this was a big experience and a very interesting experience for us in the lab, because we were ready to go, but we didn't receive so many samples in the beginning. But you can see here that when we started, we had the capacity for 2 test lines, and you will hear more about the second one later. But you see the current throughput, and we have that today, approximately 6,000 samples in the pipeline, where we have a RNA extraction step prior to the qPCR step. But then we have another pipeline with approximately the same capacity, and the number of tests when we started was approximately 500,000. Now we have used almost half of it, but we still have a high capacity. So if you want to follow what we are doing, this is one opportunity. We have this web page for the National Pandemic Center, and here you can look at the total tests, the daily tests, and the daily positive fraction, and so forth. And here you can see that in the beginning, to the left, we had quite few samples, but there were quite many positive samples at that time, because the major part of this pandemic where we had lots of positive cases was in April, May. But you can now see the red bar, that is a very minor part of the total numbers, that is representing the positive ones. And today we see approximately 1.5% of the tests that come in that are positive, compared to 10-12% in the middle of May, in the beginning of June. So the total numbers today that we have analyzed in this platform is approximately 170,000 samples, which is quite a lot, and we can see that the trend is now that the number of positive cases are decreasing in the region of Stockholm and Västra Götaland in Sweden. And this is a trend in the entire country. We hope it will continue like that. I will just also mention that on top of this detection of the virus, we have also, thanks to this sequencing infrastructure, been able to sequence positive cases. And today we have sequenced approximately 2,000 strains, and we are doing bioinformatic analysis now. And we are very interested, of course, to add more regions from Sweden and also get more metadata linked to each sample. But the first thing will be to deposit these sequences on GIS-aid, so it could be available for the community. But the most fun part here, in my opinion, is to get support from the young scientists. This is from a daycare center outside Gothenburg. And you can see that they are writing to the researchers that perform research on the coronavirus at the Karolinska Institutet. And we got lots of suggestions here. And this one on the lower right is a robot that not only detects but also eats virus. So this is a very nice experience, and we were very happy, of course, to have this support from the daycare center. So thank you.
Thank you very much, Lars. Do we have questions? And I look at Maya that received the questions.
Yes, we have one question, and for all the audience at home, I want to remind you that you can send in questions on the homepage menti.com and use the code 201010 for those of you who cannot see it on the screen. But Lars, we have a question. What will happen with all your instrumentation and lab when the pandemic slows down?
Well, first of all, we don't know when the pandemic will slow down. I mean, even if the numbers of positive cases are low now, we have a record of cases tested. So we don't know that when that will happen. But of course, we have a plan to have some kind of preparedness for the next pandemic. So the plan is to actually use these instruments in future outbreaks, and that could be not only virus, it could also be high throughput analysis of antibiotic resistance, bacterial strains, for example. So we hope that we can use this equipment in the future to be prepared for the next outbreak, whatever it is.
Thank you.
Okay, again, thank you, Lars. And I think, Maya, you can repeat it once more for those that don't have a picture. And you can send questions to all the speakers during the entire seminar. So in the end, we can have some time that you all get up here on the stage.
So the homepage is menti.com, and you enter the code 201010
Okay, thank you. And now it's a pleasure to present Adil Mardinoglu, who is running a research group at KTH SciLife Lab of some 20 plus people in the division of systems biology. You also hold a professorship in systems biology at King's College in London, I know that. And you are a true wizard, as I see it, in using mathematical models of our metabolism to understand human diseases based on the different available omics data that we have today. And you will share a lecture called Turkish Delight, Experience from Testing More Than 1 Million People. So Adil, the floor is yours.
Hello. First of all, thank you so much for the kind invitation. Today I will talk about my experience in Turkey, since actually I was locked in Turkey during the travel ban. So of course, I was having a continuous interaction with SciLife Lab, especially with Matthias and also with our team at SciLife Lab. And we decided to actually look for opportunities to do something for the country. So in that context, we've seen the issues and difficulties in providing more tests to the people. And after having continuous discussion with our colleagues here in Sweden, we decided to open some test centers. Before getting into and telling you more about our experience, I want to tell you about the current situation in Turkey. So the thing is, in Turkey, we had the first case on March 10. It was slightly later compared to Italy and also compared to other European countries. And unfortunately, we had the first death due to COVID-19 on March 15. And of course, the moment that we understand the importance of testing, the government started to take some initiative and create some testing centers. By March 29, 2020, actually the capacity of the country was around 9,000, almost 10,000. But we also know that there was a huge demand, and the waiting time for the testing was more than 48 hours. And here you see the number of cases per day. We had the peak time around April, and it went up to 5,000 per day, new cases. And unfortunately, during the summer, it actually went down to 1,000. And unfortunately, now it's going up to 2,000 again. And if you see the deaths per day, it went up to 120 and decreased down to 20s, and now unfortunately going up again up to 50s. So there is still a huge risk in the country even though people are using masks, even though they are trying to be careful, but because of the cultural behavior, unfortunately, it's a little bit difficult to keep the distance between the people. So here you see the number of the tests per day. Basically, the country started with 10,000 capacity per day, and they were actually having tests in every city. But unfortunately, there was no reference lab and there was no big initiative. That's why they were using the machines inefficiently. So in each center, they were having 100 or 200 tests. Even though all the research groups were trying to do the best, the maximum number they could go was up to 1,000, let's say 10,000, and with all this effort, it went up to 20,000. So after seeing such incidents in the country, we decided actually to see what we can do and if we can actually establish a reference laboratory and see if we can actually open a test center, since it's at the end of the day it's a PCR test, and comparing to the complicated methodologies that we use in Sweden, it's actually one of the simplest methods. So we decided to contact with the Ministry of Health first, and we asked actually if they allow us to do it for free of charge and and which will be paid fully by the government. And the minister approved our application by 28th of March 2020. It was actually on Friday afternoon. So we talked to the hospital management in Istanbul, and we started to actually make the construction and wanted to open the test center. But when we were getting the application, when we were making our application, we actually promised to minister that the capacity will be 5,000 and we would reach that capacity within 1 week. Of course, we didn't have any laboratory, we didn't have any equipment, and we didn't have any personnel trained. But we were very lucky that once we put an ad on Twitter, we actually had 500 applicants who want to work there voluntarily by Friday night. And also we talked to a construction company, and they told us they can actually fix everything during the weekend. And also the supplier, especially for the cabinet and the PCR machine, told us that they can actually deliver all the equipment on Monday. We also borrowed some equipment from some of the universities that are not using the PCR machines since they were closed because of the outbreak. So by Monday afternoon, we actually opened our test center. And this is how the construction, how we got the place. This was actually a storage of the hospital. We converted to the first of the sample collection, sample preparation unit, and then later on put all the equipment in the laboratory that we built. As I mentioned, here you see the real-time PCR working area, and we started testing on Monday. And by Monday afternoon, after we start, we actually completed the testing of 1,000 sample. Of course, we also wanted to see, first of all, we wanted to see if we can actually make it simpler. That's the reason that we did our best to avoid the RNA extraction emissions, because it was actually almost impossible to get the automated ones, because there was a huge queues. And I should say that the team in Sweden was extremely lucky. Even though we wanted to order and we wanted to pay a little extra on that, it wasn't possible in a reasonable time. That's why we search in the companies who are providing the test, and we eventually decided to move with a test which is actually without the test that is not requiring RNA extraction, and which was also looking at 3 different regions to have a correct result. In addition to that, we also included another equipment, which is Droplet Digital Pcr, which is actually improving the sensitivity and the accuracy of the results, because in some cases we didn't have the agreement between the COVID-19 result and the clinical outcome. Even though some patients had COVID-19 based on the clinical outcome, we actually seen that there is not agreement with the result of the PCR test. And of course, we blame the viral load of the patients. But instead of waiting and if some time or in case of delaying the treatment, we decided to use this Droplet PCR, and we actually get some more accurate results. The moment that we had any positive result, we also sequenced the samples, because in our case, we weren't sure about the origin of the virus. Around March, there were some people actually who visited Saudi Arabia because of the Hajj or because of the Umrah, and we find out that that could be one of the reasons. And also there were some European visitors actually who were visiting the country, and we wanted to also collect some information for vaccine development, so we can actually understand which strain we would be focusing on. So in the laboratory that we actually had the real-time PCR. We had 8 of them, and we were planning to go up to 10,000 per day. And we also droplet digital PCR, which is actually more sensitive. And if we had any disagreement between the sample and the test result, we use the droplet PCR. And we also sequence the positive ones to see to actually understand or to find out about the region or the source of the virus. So here you see our algorithm. So if the real-time PCR test result is actually positive, and if it is in agreement with the clinical outcome, it is considered as positive. The moment that if it is negative, we actually use the droplet PCR and finally see if it is positive or negative. At some stage, we also tested the influenza, but during the summer, we didn't need to test the influenza virus if there is any disagreement, since it was not really common during the summertime. The thing is, within 1 month, we were able to increase, because we didn't only open one center. The moment that we showed that we can actually get that number within 1 week, basically 5,000 tests per day, the minister actually asked us to open some new centers. And within 1 month, we were able to increase the number from 10,000 to around 40,000. And with a similar context, we actually opened 6 different research centers in all research and training hospitals. And as you see, there was actually the minimum capacity of the test centers were around 5,000. The reason is there was a huge demand. Even though there were some more city hospitals, even though they wanted us to open new centers, we couldn't manage it, since we were limited with the PCR machines. So we also opened another research test center in Ankara, and also another three of them in Izmir. So these are the big cities in Turkey. I should say that after we opened these 10 centers in different cities, we actually decreased the waiting time for the test result to 12 hours. So the moment that they collect the samples, if it is delivered to us, within 6 to 9 hours, we were able to provide the results. After we had actually an efficient communication with the Ministry of Health, the Minister of Tourism also contacted us and asked us if we can actually open different test centers in the airports, since Turkey is a touristic country, and they were actually doing their best to open the country for the tourism. So in that context, we opened 3 of them, one in Istanbul Airport, one is in Sabiha Gökçen Airport, and the other one is in İzmir Adnan Menderes Airport, and with the total capacity of 25,000 per day. So we can actually start testing the people at the daily basis. So by yesterday, we managed to test, in 1 day, we performed 110,000 tests, PCR tests, and I should say that around 75,000 of these tests have been actually performed in our facilities. The moment that during the summertime, the demand for the number of the tests is actually significantly decreased, and in that context, we checked if we can actually use this facility for screening the employees in the factories. And in that context, we run a pilot study in Kocaeli region, which is actually a city just neighbor to Istanbul, very close to Istanbul. But it's an industry city, and it is actually there are so many big companies are located in there. And in Kocaeli region, we screen 200,000 people actually within 1 month, and see if there is any positive in the working environment, and see if we can actually remove them and continue running the factory. To be honest, I should say that we had a great advantage of that, because during that pilot project, during that 1 month period, none of the factories, none of the facilities have been closed or had any issues. We were able to detect the COVID detect the patients with the COVID-19 at early stage, we were able to actually initiate their treatment and also remove them or isolate them from the work environment, so which allow us to actually run the facility continuously. And I should also say that unfortunately we stopped doing it in August and also in September, and the same facilities are having serious issues, and that's why we definitely think that in the work environment there should be continuous screening for the patients, especially in Turkey, where we are not that careful about the social distance and the masks. So we similarly start screening the people at the airport, and here I want to show you one video where we actually how we collect the samples, how we run the samples, and how we give the results within 2 hours. And after that I want to acknowledge. This is Islam. This is İzmir Adnan Menderes Airport. It's actually very close airport to touristic areas in the Mediterranean Sea. These are the units that we actually built for collection of the samples. And this is an airplane coming from Germany. I should say that we collected 180 patient samples within 15 minutes, within 10 minutes. And out of 185 people, even though the plane actually arrived there with the huge delay, one person only had an issue in providing the sample, and she actually told us that she had an operation in the nose. Other than that, no one had any complaint. Of course, this was a test that is provided free of charge, and people waited there 1.5 hours, and we actually provided the results. And out of 185 people, one person had a positive result, and we actually isolated him right away and sent it to hospital. With that, I would like to thank for the audience, and would be happy to answer the questions if there is any.
Wow, thank you, Adel. That's amazing. Questions?
Yes, we have some questions. We have two questions that come from two different people. How fast is the mutation rate of the virus, and has there been any significant changes detected in the viral DNA?
The thing is, in our case, we haven't actually seen a mutation that is affecting the clinical outcome. So when we sequenced the viruses, we had two sources. One of them is actually coming from Europe, and the patient come from France. That's how the country got the virus. And the other one came from Saudi Arabia, and it was two different origin. But in terms of clinical outcome, we couldn't see any clinical differences in terms of severeness or in terms of seriousity of the disease.
And another question, can we expect new strains emerging?
I mean, that's why we continue sequencing the virus, the source of the virus, and I think the time will show it. But we are now preparing in Turkey, and also the same in Sweden, for the winter time, since there will be some complications during the winter due to the influenza as well. So.
And we just got another question in. Was there any follow-up or tracking for the people who had shared a plane with a positive case?
Yes. What we did is, but the beautiful part in our case is, we actually get this 185 passenger, and we tested all of them at the same time. And we also carefully asked them to keep the social distance at the airport. So at the moment that we seen one positive result, we isolate him directly. And actually, he was very happy since his whole family was waiting him at home. So he was happy that he hasn't infected anyone. But when we screen the passengers around him, after 3 days, we couldn't see any positive results. So after 3 days, we followed these people as well. And we also told them to isolate themselves since the guy who's sitting close to them was positive.
Thank you.
Thank you.
Again, thank you, Adil. This was really Turkish delight, and I'm sure there were some lessons learned from this, so thank you. Okay, then we move over to Professor Sofia Huber from the Royal Institute of Technology. You're a professor in molecular biotechnology and heading the division of protein technology. You're an expert in protein engineering, and you have even developed your own protein scaffold, which is used to both diagnose cancer and combat cancer. And you have been involved in the Human Protein Atlas project, and by then been exposed to really high throughput lab effort in protein expression and so forth. And with that insights you will give us the lecture, The Antibody Experience, the Value of Serological Tests. The floor is yours.
Thank you so much, Stefan. So I'm happy to be here, and as I would like to change gear then, because I will talk about antibodies instead of virus, even though they are very much connected. And it's those that have been presenting here today say that everyone would like to help. I guess that was our take on this as well. So I have a colleague, Meher Hammar, who called me an evening and said, we can't just sit here and watching, we have to do something. And then we discussed, what are we good at? And as Stefan said, we have been involved in building the Human Protein Atlas, and we realized that we are good in measuring things, and we are good in producing proteins. And with these two experiences, we must be able to put up a serological test, because what we need is viral proteins, and we need some way to detect them, antibodies that are binding to them. So why would you like to have a serological analysis for COVID-19? I guess that all of you know that, because it has been a very huge discussion about this topic during us. Since May and forward, everyone would like to test if they have antibodies, because if you have antibodies, you are free to act whatever. So the benefits would be to ensure who's already had the disease, and to investigate, of course, how long would you have the antibodies that are still responsive to the antigen. And then I guess if we get a vaccine, we would like to prioritize those that haven't had the disease, and then it's good to know if you have had it. So it's like a complement to the viral test. Of course, it's best to catch it already when it arrives in your nose, but sometimes you don't do that, and then it could be good to afterwards being able to see if you have had it. Available tests. Today, we have been heard a lot about the PCR test, which you can see here in the beginning of the slide. And that's something that you do early on when you get the disease. You feel a bit sick, and then you send your sample to Lasse, and he will see if it's COVID-19 or something else. Then you can also test for antibodies. You can test for IgM, and that's antibodies you have to have early on in your infection, and then IgG, which you can detect after a while, and then you probably keep the antibodies for a while. So you can see here, in orange, you can see the viral antigen when you have that in your nose. And then you can detect IgA and IgM, and after that you will develop IgG. And IgG is the antibodies that you mostly detect, and that's also the antibody that you keep in your body for a longer time. And as you also probably know, we have the point-of-care test, the snabbtester in Swedish, which you just take a finger prick, and it takes 15 minutes, and then you know if you're positive or negative. And you can also send your blood to a lab and detect antibodies with different parallel methods, ELISA and Luminex. And as had been discussed quite a lot in Sweden, many of the lab analyses are kind of safer than the point of care. So what are these doing? When this SARS-CoV virus arrives in your body, the body tries to combat that, and thereby develop antibodies to the different parts of the virus. And as you can see here, we have a lot of different parts in the virus, even if it's a small one. Inside you can see the RNA the one that Lasse is detecting and also Adil in their assay. That's built together with a protein that we call nucleocapsid. We also have the envelope, the red part, that is not proteins but fatty acids. And then the orange part, the spike, the pink part is a spike, and that's the protein that the virus actually uses in order to get into our cells. And then you can see other proteins also in green and blue. And in our endeavor, we have tried all these different proteins to see if we actually produce antibodies to them. And we test the M protein, we have tested the HE protein, and the E protein, and those proteins actually give us response in all different samples, also those that haven't had the disease. So the proteins that actually give a good and selective, depending on what version of these proteins you're using, is a spike where you can see in pink, and the nucleocapsid that is packed together with the RNA. And in order to find out that this was the case, we decided to try to produce parts of all these different proteins, starting with the genome from the virus and synthesizing the different DNA parts, producing them either in bacteria or different mammalian cells, but we also made peptides to see if those small pieces of the proteins could act as antigen. Then we decorated different beads with all these different parts. And here you can see that the beads are actually color-coded, so every different protein has a specific color code, and thereby you can analyze all antibodies against all these different antigens in the same sample simultaneously. So we put all these different beads in plates with 384 different wells, and then we add on the patient sample. And the patient sample will have antibodies in it, it always has. And sometimes it's antibodies that actually could bind to any of these beads, the proteins that decorate the beads. And then the equipment we're using detect the color of the bead and also if there are any antibodies on the bead. So then we can see if there are antibodies to a specific protein because they are color-coded. And here you can see the very first analysis. As you remember, when COVID came, some of us were working from home and some of us working at the offices, depending on what you were supposed to do. And in this case, not everyone could be at the office, but everyone would like to be part of this. So you can see during this first analysis, all lab partners was actually Zooming together with Jenny that is running the equipment. And you can understand that it was a fun moment, because we could really see that our different variants of proteins could give us a lot of information, but we also could see that we could differentiate between positive and negative samples. And here is just a picture where we run 380 different blood samples, but also a number of different versions of the proteins. You can see on the y-axis we have different proteins, and on the x-axis different samples. And the lilac here means that we have a positive signal, antibodies that bind, so that specific protein. And when it's yellow, there's no signal at all. And on the top of this picture, you have the different peptides, where you can see that almost all samples actually are yellow, meaning that peptides didn't work in our hands. But in the lower part, you can see lilac cubes or lilac dots, and there you can see that we have actually samples that have reactive antibodies. And you can also see that samples from 2090 are almost blank here, but we have some background intensities that shouldn't be there if that protein were selective to patients with COVID antibodies. We have some samples from people that we know has been ill, both from Karolinska Institute and also from Folkhälsomyndigheten, and you can really see that this method can differentiate between people that have had the disease and those that not have had the disease. But it's not very easy, and I just would like to show you the viral antigen, the nucleocapsid, the one that is inside the virus. And depending on how you produce it, in which version you produce it, it will be very differently selective. Here you can see to the right in every cube you have the positive controls that we know have very high signals of antibodies. In the middle, we have the negative controls that shouldn't have any lilac dots or any signals. And when we evaluate the sample, we use 6 standard deviation from the mean, and that's where the dotted line is. And if you look at the nucleocapsid that we have produced in E. coli, you can see that there are some gray points there that actually should be lilac, but they are gray here. So when we are using this, only this antigen, we would report out that some of these people didn't have the disease, but they had it. And you can also see here when we are using the N-terminus of the nucleocapside, we have a lot of other the samples that are actually showing negative results, but they are not. And you can see the C-terminal of the nucleocapside far to the right from your side. And there we can actually catch all the positive samples are positive in that when using that antigen. So depending on what you're choosing, what part you're choosing, but also if you produce those in bacteria or in mammalian cells, you will have different answers. So you really need to be careful with the antigen you choose, and also be careful to see that the new produced antigen behaves similarly. Yes, I skipped that one. And here's also a picture on the antigen and the different signals, just to show you how complicated this is. Here you can see the spike foldon, the pink protein on the virus that you saw before. Here we have just control samples. On the left side, the negative samples, and on the right side, the positive samples. And you can see clearly here, the lilac here, there are samples that give such a high positive signal, so we should refer them to, call them positive. So you can see that we have negative samples when using the spike foldon that actually reports out as positive if you're only using one antigen. And similarly, you have the nucleocapside C-terminal. There are also some people that actually has antibodies, but they shouldn't have antibodies because they have never been ill. So the negative samples are blood from 2019 or older. And this is with a signal intensity that is linear, but if we also plot this as exponential, you can see that it's even worse. These negative samples, they have a lot of spread when it comes to signal. So if you should use only one of these antigen, you need to put the bar very low in order to ensure that you're not reporting any false positive, but only those that actually are positive. That you don't want to have any lilac dots at all on the left side of these columns. So if you're using only the nucleocapside, of course you will report some of these samples wrongly out. So what we realized when we look at our data very carefully, we could see that if you combine 2 different antigens and you say that you need to have a positive signal to both these 2, then we could actually sort out this really good. So here is an example if we are using these 332 positive samples. And we are using only the receptor binding part of this pink spike protein, meaning the part of the protein that binds to the human cell. Then we see that in the positive samples, there is one that actually don't have antibodies to both of these proteins. So we will report this guy false negative, but he is positive according to the PCR tests. In the 1978 negative samples, you can see that there are people having antibodies against the RBD, 139 plus 25, and 63. So here we would report 25 people out that actually shouldn't have antibodies. So this gives us a specificity of 98.7% and a sensitivity of 99.7%. So this is really good anyhow if you compare it with those different tests that are out there in the different companies that are screening people right now. But we were not happy with this. We thought that we should come even higher. So if we then combine the full-length nucleocapside, not only the C-terminus, we get a higher specificity, and that's most important. Here we just report out 3 people that should be negative as positive. But on the other hand, we have a lower sensitivity, because this is only 97.3. Here we should actually report 9 people negative. That should be positive. And now I showed you the combination that we actually choose to report out in our system. We have now reported out 55,000 different people, positive or negative, when it comes to antibodies. And here you can see, if we use a full spike, all pink protein, we have 332 positive sample, and only 1 individual does not show any antibodies. And when it comes to the negative sample, 37 people had antibodies against these foldon, but they never have had the disease. On the other hand, none of these people have antibodies against the C-terminal of the nucleocapside. So we are not picking any false positives, but we have 1 negative sample. And this negative sample is a very special, I think. It's a young person in the 18s. He has been confirmed having PCR positive COVID. He has been ill, having fever and coughing for 3 days, and we can't find any single antibody. So it doesn't, this guy is not under the level of reporting. He doesn't have any antibodies. We can't detect any antibodies. So this is kind of interesting. So then I start to think, is it the PCR that is false positive, or is there some people that do not produce antibodies? Because in our set, this person is the only one. So we are very happy with our method, and we are happy with what we can report out, because we think that our reporting is rather or very safe. So now I will spend the rest of my time to talk about the community. And the community is a cohort from Danderyd Hospital that we have been sampling and analyzing. We have looking both on the patients, but today I will focus on the personnel working there. So we have took blood samples from 2,149 individuals in end of April, beginning of May. It takes 2.5 weeks to sample all these guys. And we looked for several prevalence, and we asked everyone for symptoms and if they thought they had been ill, and if they were ill, when did the onset was. And also we looked at COVID exposure, meaning where have they worked in the hospital? Did they work with COVID patients, or did they work in the office, or where were they and what kind of employment they had? And the result from this was that almost 20% of the personnel at Danderyd Hospital had antibodies. We couldn't see any difference between the different groups of men or women, and not either difference between different ages. But what we could see, first looking at the symptoms, and I think you probably heard of this also, but we could see that 9% of these 9% of the people that had been ill, it was 400 something, I don't remember exactly, reported no symptoms, not even headache, from January until April. 78% reported mild symptoms, and 13% thought that they were severely ill. And you can see here that the symptoms that actually connects mostly to COVID-19 is loss of smell and taste, anosmia and ageusia. If you have those two, you can be rather sure that it's actually COVID-19 you have. And if you combine these and also having fever, you can see that we have a quite high odds ratio or a very high odds ratio that you actually have that disease and nothing else. So it might be as good as any test if you lose that and have fever. On the other hand, shortness of breath, sore throat, and runny nose, it's most like any influenza you can have. So it's not very specific. And when we looked at the patient contact, and this is really interesting, I think, we could see that if you don't have any patient contact at all working at office, those people have 9% antibodies, or the people that working in the office, 9% of those have shown to have antibodies. And that was about the same that Folkhälsomyndigheten measured in Stockholm at that time. On the other hand, if you worked with patients, 21%, that's really many. And if you divide those patient contacts to COVID patients and no COVID patients, you can see that you had a high risk working with COVID patients, but not very much higher. You can see that those that thought that they were not working with COVID patients was almost the same grade of antibodies as the others. So probably the sorting of the patient wasn't really correct here. And if you divide these into different departments, if you worked at the emergency unit taking care of COVID patients when they arrived, 26% of those had antibodies. And in the top you can see the numbers of in each group. Wow. And working at the sorting unit where you actually divide the COVID patients from the other, 27. And then it was a little bit better working in the EVA or in the intermediate care units. And what we also could see was that if you was assistant nurse, then you were in really high risk to get the disease. And the nurses, second high risk. And if you other medical staff that did not have so much patient contacts, they were not as sick as the others. And that's quite obvious because the assistant nurses, they are those that actually take care of the patients sitting beside and take care of them. And I think that we can conclude that we should use more masks at the care units in the hospitals. Now we have started to sample all the people again, both the patients and the personnel. And all personnel were happy to be part of this again, and we are really happy for that because now we are able to follow them. And the idea here is to see how many still have antibodies, how many new cases do we have since May, and how long is the duration for antibodies in the blood? Are that dependent on how ill you were, or is it dependent on how much antibodies you had when we measured this last time? And we also would like to see if the antibodies neutralize or not the virus to get into the cells. And we included also in this study to look at T-cell response. And that is, of course, interesting to see if there are people with T-cells respond with no antibodies, or if it's mainly those that have antibodies that show T-cells response. But I will come back to that later in a couple of weeks or so, when we know more. This huge project, there's a lot of people to thank. All Tegel Lab, Hedama Lab at Alba Nova, working with the proteins, Nilsson Lab that run the assays at SciLife Lab, and also Tolin at Danderyds sjukhus and her personnel that has been really good in sampling and all other things. Funding, Erling Persson, Wallenbergstiftelsen, Atlas Copco, Region Stockholm, och a lot of other engaged people. And also I would like to mention Agnes, who made all these bracelets, sold them and gave the money to our project, and 11 years old. So a lot of people has been really engaged, and I'm happy to take questions if there are any.
Yes, Sophia, we have some questions. Hey, Sophia, if you say that you report every PCR confirmed case also antibody positive, what does that mean for T-cell immunity and its relevance or rate of occurrence? And that's from Tarek.
Yeah. Hey, Tarek. Yes, I'm not sure about if it's due to what we see. We have run 332 samples here. Of course, there could be samples that we haven't run, and we shouldn't find antibodies in also. But it came also a publication in last week, I think, in Iceland, where they have actually analyzed all people with positive PCR, and I think that was a number of thousand. And they found actually antibodies in 90% of these people. So it might be that we don't have sensitivity enough in the assays that are run, or it might be that it's too far from the onset of the sickness to the sampling of the antibodies as well. So I mean, the people that were sick early on in March might not have so many antibodies left in May, but only B cells. That could be an explanation.
And then we have a more personal question, very short answer. What has it been like for you to be spotlighted as the spokesperson of antibody testing in Sweden?
No comments. Yep. Thank you.
Thank you, Sophia. Impressive dissection of the protein, what to use in the test and so on. Okay, over to the last speaker. I would need about an hour to introduce Matthias Ullén properly. He's a professor at KTH and also guest professor at Karolinska. He has some 650 plus publication, 63,000 citation, H index 119. You have a long and broad research experience and portfolio around proteins, everything from finding them, understanding them, engineering them, and now by heading the Wallenberg-funded Human Protein Atlas project, where you have mapped all human proteins with a humble goal of understanding the human diseases, create diagnosis, and also find cure. That's quite impressive. And now you will share something completely different almost. What have we learned from the Swedish strategy to combat COVID-19? The floor is yours.
Okay, thank you very much. That's quite a grandiose title, I guess. I did not know 6 months ago that I would be standing here talking about something that I never done before. But I'm very grateful to a lot of people that have helped me in this journey, and you have heard actually 3 of them today. So we have Lars and I, we were in China and we got inspired and we got a lot of help. Adil and I, we almost talked every day when we were comparing notes between Sweden and Turkey. And Sophia has helped us a lot to do a combination studies with the antibodies and PCR. So what I thought I would do then is to give you some pilot studies to give you a flavor what has happened in Sweden, but also how I see how we should continue then. So this is just to remind you that we haven't been very successful in Sweden. We are one of the countries in the world that has the highest excess mortality during March to May. But since then, something very positive has happened, and actually now the excess mortality in at least in Stockholm is actually less than last year. What we have done is, together with Lars Engstrand then at the Biomedicum in Karolinska, then set up a parallel test platform as Lars was describing, using another system very much inspired by the Turkish delight that you heard about, and set this up in order to allow mass screening with a rather large capacity, as Lars was saying. We have used a little bit different from both Adil and Lars, that we're using a mobile app to do all the securities and the questionnaires and so on. And this has been a wonderful collaboration with a small company here in Stockholm called Addi Medical. So basically, in this way, we can do all the security, the GDPR and so on, that normally has to come through the hospital's journal system. We were also lucky to have an ethical approval done in the beginning of May, so we could start to study on the population-based how the virus is spreading in Sweden. So I thought, instead of giving you sort of the whole big picture, is instead to tell you 4 stories that we've been looking at and just give you an idea what we found. And these are rather small numbers, but they are very consistent. So the first pilot project is one of the elderly care that we done during the summer here in Stockholm. We tested quite a few different homes, and for some of them actually we have tested the whole personnel every week in order to really try to get a sort of zero vision of infections in these for these personnel taking care of elderly. One of them, the SVPH, was the first one. We started in May and June. We tested both the personnel and the guests of the elderly homes. And what we found is very similar to what others have found, is at quite a few, about 3% of the personnel actually had infection. What it was most dramatic here is that almost all of them had no symptoms at all. And obviously, if you're a personnel at an elderly home, you have no symptoms, you have no reason to stay home. So by identifying these people, we can actually ask them to go home and stay home for a week, and then we tested them again. Also, we did antibody testing through Sofia's test lab. And in this elderly home, we have about 18%, which is very similar to what Sofia was saying at the Danderyd Hospital. What was very nice is that last week we did a sweep of this elderly home and tested all the personnel, and we didn't find a single personnel which is now infected. So and again, it shows that when you do this kind of testing, you can get it under control. The other pilot study was interesting for us because it was outside the hospital system, it was outside the elderly homes. This was also in May, June, and it was a combined test, both PCR and then the antibody testing. And we tested about 1,500 people, everybody from the CEO of the company down to the, all the way down in the organization. And we found about 0.3% of the personnel at that point were infected. And again, we were quite surprised that more than half of those people did not have any symptoms. So obviously, it was very good for the company to know that they have people that are infected but had no symptoms and were still at work. And again, when we looked at antibody testing, at that time, about 5% of the personnel had antibodies to the virus, which is, of course, significantly lower than what Sofia was talking about at the hospital. But it kind of makes sense that when you have lower infection, you also have fewer people with antibodies. The third project that I want to talk about is dentists here and students at the dentist school here at the Karolinska. When they were coming back and they were they were going to see patients, it is of course nice to know that you don't have an infection. So we tested both the teachers and also the students. And again, we found very few, but some students that have an infection with PCR. And again, both of these, it was only 2, but none of them had any symptoms. So obviously, they were sent home for quarantine for a week, and then we tested them again. The fourth project is more recent. We did a lot of testing during the summer, but I don't want to. It showed sort of a decline in the number of positive tests. But this was an interesting project. This was done last week up in Umeå in the north of Sweden. All students and personnel at Umeå University were offered free testing from us for acute infection PCR. This was an interesting collaboration between the government, the Folkhälsomyndigheten, the Umeå University, the military who set up the sites to get in the samples, and also the Karolinska who was doing the lab test in our group. This was self-testing, so we had videos how to do that, and then you have to go through a mobile phone in order to get an extensive questionnaire and get the GDPR security and so on. So in the first week, which was last week, we tested about 8,000 people. We are very, very happy that of these 8,000 people, only 2 were tested positive with this PCR test. In this case, both these people had symptoms, but it does show that we have relatively few now infected, at least in the Umeå. And I also want to sort of say that the way that the people in the clinic is working in Umeå is very excellent. They go in, they have dedicated people to go around and see what else people are infected. It's also very interesting to go through the questionnaire, which came in through the mobile app. And we have, of course, not been able to do all the analysis, but it is interesting to see that about 300 people reported that they had fever and were more or less staying at home, most of them. And none of these 300 people actually had COVID, but many of them thought that they had COVID. They also had, no, actually it was 119, so about 1.5%. But about 300 have nausea, illamående. So what it does show is that a lot of the people that are staying at home, they feel sick, but they actually don't have COVID. It's probably good that they stay home anyway. So what do we know from these pilot studies? And I don't want to take too much time, but it is very clear that at least what we are seeing, but also there is now many publications coming out, is that many persons with acute infections do not have symptoms. And this is, of course, very interesting, and I will come back to that. Also, what is very positive for Sweden is that infections are dramatically decreasing. We can kind of see it goes up and down, but at least in the studies that we are doing, we see a very dramatic decline in the number of infected people. And what that is due to, we could of course discuss. When you look at how many people are tested positive, you get different numbers. And in the end of this slide, I just show you some different statistics that you can sort of see in the journals and in the newspapers, and they are kind of confusing because they say very different stories. So sometimes you hear that only I think this was reported yesterday, that only 1 out of 100,000 people in Sweden are tested positive for PCR. But this is of course the ones that are tested, and of course there are people that are not tested that still have COVID. But it is nice to see that both in Denmark, Sweden and Norway, this number is between 1 and 2, so it's very similar now and very low. Then you have another estimate, and that is the estimate that kind of Lars is seeing, which is getting samples of people that report they have symptoms and then they are tested. And right now, I think I would say that it's about 1 out of 100, about 1%, maybe 2% are tested positive. So that's a much higher number, of course, than 1 out of 100,000. And then you see the population testing that we are doing, which I think is the real value, because there we are taking a sweep and we are testing everybody, even if they don't have symptoms. And at least our numbers from last week in Umeå is about 1 out of 4,000. So you can see we're going from 1 in 100,000 to about 1 in 4,000. So what have we learned then from this? I started with 10 different points, but I tried to minimize it to 4 main lessons, at least I have learned from this pandemic. And the first one, I think, is very important, and that, well, actually, I'm going to go through them more in detail, so I will do that on the next slide then. The first one is to try to introduce test procedures to identify persons and try to do it as fast as possible. You kind of heard what Lars was saying, what Adil was saying with PCR tests, to try to get them in place in weeks, or maybe even, as in Adil's case, in days. Because it is very important to know which are infected or not. So And actually, in the end of March, we had a debate article in DN. Lars Engstrand, myself, Siv Andersson from Uppsala, and Göran Sandberg from the Wallenberg Foundation. And what we said in that article, I still believe very much in. Of the main theme was that excessive testing must be set up rapidly to identify persons who are infected, but also we have to be able to prioritize personnel in hospitals, in healthcare, but also in elderly care to protect these people from infection. And at this time, I also want to thank the Wallenberg Foundation, because at the same time as this DN debate article came out, they gave this very generous support to Lars Engstrand and his team at the Karolinska to set up this new lab that you heard of. And without the Wallenberg Foundation, we wouldn't have that test capacity. The other point that I want to make is that a large portion of the infected persons have no symptoms. The statistics from different countries are remarkably similar, and that is that between 30 and 40% of the people never gets any symptoms. So you can sort of divide in the infection or the COVID-19 into 3 stages. The asymptomatic stage, where you have no symptoms. And then about 60% of those moves then to the next phase where they get flu-like symptoms. And then you have, then you can of course stay home. And then about 3 to 4% of those then moves into this very serious phase where you have to stay in hospitals and you even have to have very intensive care, and in some cases die. So there is this very interesting group and very dangerous group of asymptomatic people that goes around, have the infection and have rather high viral titers. And there is a lot of different publications now coming out saying that the viral load of the asymptomatic persons are in some cases as high as those with symptoms. So what does that mean then? Well, that means that we have to take into account that people without symptoms might spread the disease. A large fraction of the persons with acute infections have no symptoms, and they can spread the disease. And we had another debate article in Dagens Nyheter, Lars Engstrand and me, in the end of June. And we said exactly this at that time. That we need to take this into account, and I think this is very, very important. The other point that I want to make, and it's really from the very frustrating journey throughout the months since April, together with Lars Engstrand, and that is we should in the future try to avoid the need to adapt test procedures to regional IT systems. In Sweden we have 21 regions. Each one of them has different IT systems, and in order to be able to use the journal systems, the IT systems, the documentation systems in these regions, you have to adapt the test procedures for these. And I think this has hampered a lot of the test capacity, and I think it's very important that we try to avoid this. And then the last one that I want to point out is that I think it is important then with social distancing in the early phase of a pandemic. Since so many people are asymptomatic, we don't know when they are infecting other people. The stay at home with symptoms is not really enough to prevent spread of disease, and therefore social distancing early in the phase is important. So what we have learned then is introduce mass testing as soon as possible, be prepared next time we have something similar to this, facilitate sample procedure, try to avoid the use of healthcare system, I think, because we shouldn't have the health workers doing the test. I think this could be done outside because they should be treating patients. And take into account that people can be infected, be infectious without having symptoms. and then have protecting gear in the early phase. But we can't have social distances forever. At one point, we have to move away into a more normal situation. And that is what I call the later phase of the pandemic outbreak. I don't think that we're there yet, but I hope that we can actually enter this phase relatively soon. And then, if we do that, I think one of the most important part is to be able to do at that time extensive testing of everybody having contact with persons with acute infection. Do smittspårning very rapidly and very efficiently in order to then identify people that are infected. And then maybe move away from social distances of the whole population and then go into clusters where you have infection and then have social distances around those. So we are not there yet, but I think a lot of things looks very nice now in Sweden, but obviously we have to then be on our toes in order not to let this devil, the virus, get loose again. Thank you very much.
Yes, we have one question for you, Matthias, and then we have some questions that might be general for all the speakers. How accurate is self-testing compared to tests done by trained people?
It's a good question. We think what we have used is a rather careful self-testing procedure where you take both the throat, the nose, and then also spit. We believe it is a very accurate way of doing it, but obviously we also have controls in the assay that shows if the self-testing has been correctly done, and we do get tests that we have to report that they haven't done it correctly. So, but of course we cannot guarantee that people are testing themselves. They can test their children and so on, but we are hoping that people wants to know that they are themselves testing and if they are infected. So, but I do think that the procedures that have been worked out now in these 6 months are rather accurate, even for self-testing.
Thank you.
Thank you.
So take a couple of questions more to
For all the speakers. Yes, we have a few questions actually to Lars that came in after your talk. Based on sequence data, can we conclude where most Swedes got infected?
There are many centers that have performed sequencing so far, and we can see, I mean, the Folkhälsomyndigheten reported that we have I mean, viruses are coming into the country not only from northern Italy but also from France, England, and United States in the beginning of the disease. But this is, of course, something we want to study more deeply now by sequencing more isolates from different regions in Sweden, and we can see that just 1 out of 2,000 isolates came from Wuhan region in our population in Stockholm. So that tells us that we have imported these viruses from other areas in Europe, especially.
Mm. Thank you. And to most of you, I guess, is contamination between samples a problem when handling these large numbers?
So I can start. I think it's very important to have all the procedures automated. We try to avoid manual operations as much as possible. No, I think it's fairly safe procedures that are implemented in most cases.
Yes, I agree. If we work very much in robotics that actually move the samples from a plate to another, so the mixing between samples, that risk is very low.
Yeah. The moment that we actually, even if there is a mix, so we will detect the positive one, so then definitely we have to repeat that plate anyway. So I don't think that contamination will be a major issue.
Okay, I think need to end there. And it's said that I should do the concluding remarks. I think, first of all, Matthias concluded very well. I could say in another way, for me, you're true heroes. You set aside your research and straight into an endeavor to solve a problem in the society. That's so impressive for me. That's my biggest concluding remark. Then, of course, we have learned a lot, as we have seen, concerning we need this equipment available at the next pandemic, because this won't be the last one. We need the methods available. We need skilled people. We need harmonizing between different regions and able to do this. And we need, of course, to do rapid testing who is got infected. And we want to see who has developed antibodies so they can meet their close friends and so on. So I will not do any further than that. Say you're heroes, and thank you very much for the seminar.